Let's do some MCAT-OChem.
Rank each marked atom by acidity if the compound shown reacts with NaOH. All right, so acidity refers to stability of a conjugate base, right? So let's just say we have an arbitrary CH and it got deprotonated, it lost an H. It's going to look like C minus, right? So this is the conjugate base essentially. And we're looking at the anions of each of these, right? If they lost an H, and we're comparing those by stability. And the more stable the anion is, the more acidic it is. So let's just start looking at each of them. I'm not going to draw on here. I'm going to draw on the side, but kind of show the same thing, right? So the first one we have is an O, right? It loses its H, so it's going to become O minus. Then over here, we have, right, this is the carbon, right, that lost this H, so the minus charge goes right here. Then let's continue this. Now we have this methyl up here, and it lost one of these three H's, so we're going to put a minus up here. There's still two hydrogens, just keep that in mind. And lastly, we have this ketone. It's separate, so I'm just going to draw it separately on the side. And it continues and whatever here. Then we lost this hydrogen from this carbon, right? So we have a minus right here. And once again, there's two hydrogens there. So we have 1, 2, 3, and 4. So now we're going to look at each of them. So the first thing we look at is the atom and then resonance, okay? Put these two. The first thing we look at is atom, okay? We have, this is our periodic table right here. There's more obviously, but this is the only ones in question, C and O, right? So the more electronegative the atom is, the more stable the negative charge is, right? The more stable the anion is, regardless of resonance. We're just looking at A. We use resonance when comparing elements of the same group or even the same elements, but O is more electronegative than carbon. So regardless of any resonance opportunities, this one is going to be number 1, right? Because the rest of these are carbons. So this is number 1. So we'll start with the 1 right here. Next, let's look at this carbon right here. This is right on a double bond. Double bonds, anything is bad. If you have a plus charge or minus charge on a double bond, it's bad. This is called vinylic. So this, we're not going to rank yet, but it's most likely going to be at the end, right? Given what we just said. Now let's look at this one right here. This is a primary carb anion because it has one, it's connected directly to one carbon, okay? Primary carb anions are actually really good. Primary is better than secondary, which is better than tertiary for anions. Keep that in mind. Now right here, we also have a primary, but look what's interesting about this, right? This can resonate. So if you do resonance, we get this right here. So this is primary allylic. This is just primary, and this is vinylic. Doesn't matter if it's primary or secondary, it's just vinylic. It's bad. So primary with resonance is better than primary. So this is number 4, so I'm going to have 4 next, and then 3, and then 2, which is answer choice A. Now you might be wondering, why is this better than this one if we ended up with a charge on the oxygen? This one just has a charge on the oxygen, but this has a charge on the oxygen with resonance. Well, experimentally, something like this, like an OH, would be more acidic than a ketone or aldehyde. And, you know, the best way to explain it is that just look at where does the negative charge originate. The negative charge originated on the O, whereas it originated on the carbon here. Now, it did end up resonating, but once again, experiments show that